beautiful people. So in this video, what I'm going to do is go through our Unit 3 notes packet number 2 level 4 notes. You can find a PDF of all these notes filled out on Google Classroom under our notes packet section. Okay, so to start off, the two main goals for level 4 is for us to figure out the measures of inscribed angles. And those of you who forgot what an inscribed angle was, here's the definition right here. And our second goal is to find measures of angles in inscribed polygons. And when I say inscribed polygons, we have that definition down here, and we'll go through it in more detail later. Okay, but to start off, let's take a look at how we find measures of inscribed angles. In order for us to find those measures, there's two theorems in the beginning of these notes that we need to go through. So the first one is going to be the inscribed angle theorem, and I'll put that in purple. Okay. And the second theorem is going to be Theorem 10.6, and I'll put that in green. So in the inscribed angle theorem, it says, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 of the measure of its intercepted arc. Throughout these notes, whenever you see the word intercepted, what that means is the arc that it touches or intersects. And if you hear a dog in the background, that is my dog Buko. That it touches or intersects. Okay. Algebraically, this theorem is demonstrated up here. So if we have the measurement of DEF, that's the same as 1/2 of the measurement of its arc. Okay. So as an example, let's say I tell you that arc DF is equal to 75 degrees. Okay. What that means is the measurement of that angle DEF is just 75 divided by 2, which would give me 37.5 degrees. Okay. In Theorem 10.6, it states that if two inscribed angles of a circle intercept congruent arcs or the same arc, then the angles are congruent. What that essentially means is that let's take a look at angle 1 first. I see that angle 1 is right here, and it intercepts arc DC. There's another angle, angle 2, that also intercepts arc DC. So because they both intercept arc DC, I could say that angle 1 is congruent to angle 2. Okay, there's another pair, and I'll show that pair in a different color. Let's do this darker green over here. Angle 4 intersects arc AB, and so does angle 3. It intersects arc AB. So according to Theorem 10.6, angle 4 and angle 3 are congruent since they both intercept the same arc. Okay. In example 1, you'll see the inscribed angle theorem in Theorem 10.6 used to help them solve for these angles. It says in circle S, so this circle right here, arc KL is equal to 80. So I know that this is 80. Arc LM is equal to 100. And then arc MN is equal to 60. Okay, it says find the measure of each angle. When we do these calculations, you'll see me use the inscribed angle theorem. Remember I said I'll color code that in purple. Numbers 1, 2, 3, and 4. And then you'll see me use theorem 10.6 in numbers 5 and 6. Okay. Do problems 1, 3, and 4 first, because those are just straightforward angle theorem. So angle 1, I notice, is this angle right here, and it intercepts LM over here. So that's just 100 divided by 2 to give me 50. For angle 3, remember I'm skipping angle 2 for now. Angle 3 is over here, intercepts arc MN, which is 60, so I just do 60 divided by 2 to give me 30. Angle 4, that's over here, intercepts arc KL over here, so I just do 80 divided by 2 to give me 40. Okay, so 3 quick division problems. In number 2, you're also going to do a quick division problem, but before that, we actually need to solve for arc KN, because if you look at the diagram, here's angle 2 right here, and angle 2 actually intercepts right here. In the problem, they didn't give us arc KN, but if you remember all our rules and stuff from level 3 regarding arc measures and things like that, I could use the arc addition postulate, which tells me this small arc KN is just 360 minus the sum of all these other arcs over here. So that's 80 plus 100 plus 60, which is 360 minus 240, which gives us the final measurement of 120 for arc KN. Okay, so now that we know KN is 120, to get angle 2, I just use the inscribed angle theorem, and we get 60. Cool. So 5 and 6, to use theorem 10.6, I don't need to do any calculations. If I look at the diagram, angle 5 is over here, which intercepts arc KL. Angle 4 also intercepts the same. So I could say angle 5 is congruent to angle 4. And similarly, angle 6 over here intercepts arc NM. So does angle, I think that was angle 3 over here. So angle 6 is congruent to angle 3. So our answers here would be 40 degrees, and here is 30 degrees. Okay, so that is the inscribed angle theorem and theorem 10.6. We got 2 more theorems, and these 2 theorems help us with the second goal of finding measures of angles in inscribed polygons. I'll color code theorem 10.7 in, let's use dark blue, and I'll color code theorem 10.8 in this maroon color. Okay, so first off, in theorem 10.7, it states that if an angle of an inscribed polygon intercepts the semicircle, the angle is a right angle. Okay. Like I mentioned earlier, the definition for inscribed polygon is over here, and it says it's one whose sides are chords of a circle and whose vertices are points on the circle. Basically, inscribed polygon is just a shape inside a circle, and all the vertices touch the outsides. So it says name the right angles in the figure on the left. According to Theorem 10.7, I could say angle A is a right angle and angle C is a right angle. I know that because if you look at angle A, this angle intercepts this semicircle right here. So that half of the circle, and this angle, angle C, over here, intercepts this semicircle over here. Okay, so I could say angle A is congruent to angle C, which are both equal to 90 degrees. Let me make that congruent sign more clear. Okay, and then in the example problems below, you'll see us use Theorem 10.7 twice. That's going to be number 2 and a number 3. Quadrilateral is inscribed in a circle, then opposite angles are supplementary. And for those of you guys who forgot, remember supplementary means their sum equals 180 degrees. Okay. So to warm up, it says name an inscribed polygon in the diagram. We have the definition up there. We could say it's quadrilateral. So quad B A D C. And it says name 2 pairs, that's a typo, of supplementary angles. It's just the angles that are across from each other. So we got angle B and angle D. So angle B plus angle D equals 180. And then angle A and angle C equals 180. And you'll see us use Theorem 10.8 and number 4. Okay. So in example 2, these example problems says find the measure of each lettered or numbered angle. In number 1, we actually have to use the inscribed angle theorem, which just tells us, oh, I have to find the measurement of angle E. That's just me doing 162 divided by 2, which gives us 81 degrees. Okay. We're going to be using Theorem 10.7, which as a reminder states if an angle of an inscribed polygon intercepts a semicircle, the angle is a right angle. So I know that angle B is a right angle because if you take a look, it intercepts at the semicircle. Okay, and in this problem, it tells us that angle 1 is 5x minus 2, and it tells us that angle 2 is 2x plus 8. I'm just going to change the color on this so you guys don't get confused. So this is Theorem 10.7. So the problem wants us to find the measurement of angle 1 and measurement of angle 2. I first need to solve for x, and then I plug it in to find my measurement of the angles. Okay. And then the way I solve for x, I set up my equation with the given information. Right? So I know that these are 3 angles of a triangle. So I could set up the equation that 90 plus 5x minus 2 plus 2x plus 8 equals 180. Okay, and that's all because these 3 angles add up together to form the angles of a triangle. If I combine like terms, you should get 7x plus 96 equals 180. Use inverse operations to get you 7x equals 84. And then when you solve for x, you get x to equal 12. Okay, now remember, our goal is to find the measurement of angle 1 and angle 2. So now that I know what x equals, I have to plug it back in. Measurement of angle 1 equals 5 times 12 minus 2. And then measurement of angle 2 equals 2 times 12 plus 8. So ultimately, our final answers should be 58 degrees and 32 degrees. Okay? Number 3, we're going to use the same theorem, and we're going to do the same exact steps, but I just have to do it twice. Because if you look at number 3, I have 4 angles to solve for. Angle 1, angle 3, angle 4, and angle 6. Okay? They tell us that angle 1 is 5x, and angle 3 is 3x plus 10. They also tell us that angle 4 is y plus 7, and angle 6 is 3y plus 11. Okay, I'm going to set up 2 equations, the first one to help me solve for x, and the second one to help me solve for y. Right, so like I said, like number 2, we use theorem 10.7. I know angle 2 is a right angle because angle F intercepts the semicircle. I also know that angle 5 is a right angle because angle semicircle as well. So our first equation to help us with x is going to be 90 plus 3x plus 10 plus 5x gives me 180. Okay, and then the second equation, and I'll do that in a different shade of blue, is going to be 90 plus 3y plus 11 plus 3x plus 10 equals 180. Okay. I'll do the equation that solves for y first. We use the same steps as earlier, combine like terms. Oops, that shouldn't be 3x plus 10. This second equation should be, this equation should have all y's, so this should be y plus 7. My bad. But like I was saying, combine like terms, you should get 4y plus 108 equals 180. And you get 4y equals 72 if you use inverse operations. Sorry, my pen is timing out. And I get y is equal to, let me see if I can fix this real quick. Okay, let's try this again. There we go. Y is equal to 18. Okay. In the other equation, combine like terms to get 8x plus 100 equals 180. Use inverse operations to get you 8x equals 80. Then you get x to equal 10. Okay, so if I put all of that together to get the measurement of angle 1, I just do 5 times 10. Oh no, my pen is timing out again. And then measurement of angle 3, I do 3 times 10 gives me 50 degrees and 40 degrees. And then for the last two angles, it's going to be measurement of angle 4 is 18 plus 7, y plus 7, which gives me 25. And then measurement angle 6, which gives me 3 times 18 plus 11, which gives me 65 degrees. Okay. Whew. So that was a lot of steps, but like I said, it was just like number 2. We have one problem left, and I promise this one's a lot shorter. So number 4, we have to find the measurement of angle x over here and angle y. We use Theorem 10.8, which talks about opposite angles in an inscribed quadrilateral to be supplementary. So essentially we could say angle W plus angle Y, since they're across from one another, equals 180. And I could also say angle Z plus angle X equals 180 because they're across from one another. Okay. So that just gives us these two one-step equations of 120 plus y equals 180 and 55 plus x equals 180. That gives us angle x to equal 60. I just subtract 120 from both sides, and then angle x to equal 125 because I just subtract 155 from both sides. Okay, so there we go, level 4. Remember, the main ideas is our 4 theorems, and they're all to help us figure out the measures of inscribed angles and of measurements of angles inside polygons. Okay, email me if you have questions, and I hope you guys all stay healthy and stay